So this is number 26 from the 2013 Mock Math Count Sprint Round number 1. And when you read this problem, there's two really important facts to get. The first is because they're talking about subsets, each of the exponents of these powers has to be odd or distinct, and so they have to be different from each other. The second important fact is if the product of the three elements is a perfect cube, that means the sum of the exponents is a multiple of 3. And that's where we're going to use in counting all the possibilities here. So we're going to start with a, how many ways can I get a sum of my exponents of 3? Well, the only way to do that with three things is 1 plus 1 plus 1, but that violates the distinct, so we can't get a multiple of 3. What about a multiple of 6? Well, the only possible way to do that is 1, 2, 3. 1 plus 2 plus 3. Okay, so there's only one way that's a multiple of 6. What about a multiple of 9? Now we're getting to where we're going to have some more options. So to count these, the first thing I'm going to do is I'm going to take a 1. How many could include a 1? Well, I need to add up to 8. Well, I could have 2, 6, 3, 5, or 4, 4. Well, 4, 4 doesn't work. And so there are two ways with a 1. Assuming I can't have a 1, so then I have a 2. And that means we have to get a 7. Well, the only way to do that is 3 plus 4 and not violate one of the other rules, and so there's one way to do that. So the number of ways to get a 9 is 4. Then we look at 12. Same idea. Start with a 1. Well, I've got to get to 11, and so I could have 1 and 10. Well, that doesn't work because then I've used 1 twice, so I would do 2, 9, 3, 6, and 4, 5. And so there are three ways when you start with a 1 to get 12. When you start with a 2, now we got to get a 10, but we only can do 3, 7, and 4, 6. And so when you start with a 2, there are two ways. And when you start with a 3, your only option would be 3, 4, 5, and so one way. And so there are 6 ways to get to 12, and we just keep going. 15, if there's a 1, well, I could do 1, 3, or 1, 4, 10, and then 5, 9, and 6, 8. And so there are 3 ways. With a 2, I've got to get to 13, and so I can do 10, 3, or 9, 4, or 8, 5, or 7, 6. And so for a 2, there's actually 4 ways to do it. Right? You could start with 6, 7 and work all the way to 10, 3. For a 3 on that one, there are going to be, well, you get to 12. How many ways can you get a sum with 12? So you could start with 4, 8, and 5, 7, so there's 2 ways. If you start with a 4, well, you could do 4, 5, 6, and so there's 1 way. And so in this case, it turns out to be 10. And we just got to keep going. For 18, well, if I start with a 1, the only way to get it, to get 17, is 7 plus 10 or 8 plus 9, so there's 2 ways. If I start with a 2, I've got to get 16. And if I have a 16, then it's going to be, 6, 10, 7, 9, or 8, 8, so there's only, so you get the 6 and the 10 and the 7 and 9, and that's it, so there's just 2 ways. If I start with a 3, then I've got to get to 15, and so I could do 5, 10, 6, 9, 7, 8, and so there's 3 ways. If I could start with a 4, I just got to get to a 14, and so 5, 9, and 6, 8 would work, so there's 2 ways. And if I start with a 5, and then I could do 5, 6, 7, which would give you 1 way. And so that's going to give me 6. So there are actually 10 ways to do that. Now, the key to this problem is recognizing that at this point there's actually symmetry. And there's symmetry because you could look at this as subtracting from 10 to get these. And so we can just show ourselves that real quick. But if you want to add a 1, there's no way to do a 1, but to get 2, 19, there's 2, 9, 10, so there's 1 way. And then 8, if you have a 3, then you have 18, and so you're going to have 8, 10, and so 3 has 1 way. And then a 4 is going to be 14, not 14, 17, which is going to give you 7, 10, or 8, 9, and so there's 2 ways. With a 5, you got to get a 16, which is only going to give you 6, 10, and 7, 9, so 2 ways. With a 6, you're going to get a 21, or 15, which 7, 8 is going to work, and so there's 1 way. So it turns out on this one, actually, there isn't symmetry, so there's 7 ways to go onto it. So I lied to you about there being symmetry. I was sure there would be. So that's why it's a good thing to check. And so then you just do 24. The nice thing is the last one is 27. There's only one way to do 27, 8, 9, and 10. So once I get 24 out of the way here, and the also good thing about 24 is 19 is the only thing I can get, so I only have to start with a 5, right? Because 19, there's only one way to do it. And then the next one's a 6, which would give me 18. And with 18, there's only, you could do 6, 7, or 6, 8, 10, and so there's only going to be one way to do that. For 7, that's a 17, which is only going to be the one way to do that, 8, 9. And then with an 8, well, 8 you can't do because you'd have to have 8, 8, 8, and so there's just the 3 ways there and the 1 way there. So it turns out to be the sum of all of these, which is 42. And so that was a long problem for being on a sprint round. But you could have definitely done it, and we did a lot of talking on this and had it done in 6 minutes, and so you could have easily done it in 2 or 3 minutes, which sometimes MathCounts does that, where they expect you to get to the end problems and have enough time to spend 2 or 3 minutes on a single problem.